Now that we've had the opportunity to look at mutually exclusive events or events that cannot occur at the same time, let's take a look at looking at inclusive events, events that can happen at the same time. So we have a deck of cards and we're drawing a card and we want to calculate the probability. I want to have you draw a Venn diagram. So we have red and we have 5. And we know there's going to be overlap because I'm telling you that they're inclusive. Let's start with that overlap. When we talk red 5, I know that that's 5 of hearts and that's 5 of diamonds. And so then I want to then step out of the box and look at just red. So I've got a red ace of hearts, got ace of diamonds, and etc., etc. So if I think about it, I've got 13 cards that are red hearts, 13 cards that are red diamonds, so it's 26 cards, but 2 of them are here, which means that I have 24 over here. And 5s, I have 4 5s, but I have 2 here, so that means I have 2 here because I would have my 5 spades and my 5 of clubs. And so now when we talk about that, we've got 24 out of 52 plus 2 out of 52 because it's one or the other, but you also have to count these 2 as well. And that gives me 24, 26, 28, so 28 out of 52, which if we divide those by 4, you get 7 out of 13, which calculating that as decimal and percent, 7 divided by 13 gives me 0.538 and 53.8%. Now, I'm going to look at the steps now so you can see the other way you can do this. So step 1 of the other way would be to find probability of A, which is the probability of red, which is 26 out of 52, and find probability of B, which is 4 out of 52. And then we said find the probability of A and B occurring, which is this overlap, which is 2 out of 52. And we subtract that off, so combining the probabilities, A plus B minus A and B, 26 plus 4 is 30, minus 2 gets you that 28 out of 52, which simplifies up here. I don't care which way you use. For several of you, Venn diagram is probably going to be more beneficial. So if we look at this next example, a spade or a face card, that's going to be Venn diagram looking at with overlap. Here are my spades and these are my face cards. So the first thing I want to think about is spade face cards. So that would be my jack of spades, my queen of spades, and my king of spades. Now, if we think about the other spades, we're going to have ace, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And the other face cards are going to be your jack of hearts, your jack of diamonds, your jack of clubs, and then also queen, your 3 queens, and your 3 kings. And so if we add these all up, out of each of them out of 52 cards, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 out of 52. We have 3 in the middle, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9 on the right side. 10 plus 3 plus 9 is 22 out of 52, which simplifies to 11 out of 26. And if we change that into a decimal, 11 divided by 26 gives you 0.423, which is 42.3%. Finally, we have diamond or less than 4. So we've got diamonds less than 4. So if we start with that middle area, our diamond cards that are less than 4, we've got 3, we got 2, and we've got our ace. Diamonds over here, less than 4. So we've got 3 of diamonds, 2 of diamonds, ace of diamonds that are 8 diamond and less than 4. Our other ones that we have for diamonds are 4, 5, 6, 7, 8, 9, 10, jack, queen, king. And less than 4, we also have 3 of hearts. We got 3 of clubs. And we got 3 of spades. And we also have 2 hearts, ace hearts, 2 club, and ace club. And then we also have 2 spade and ace of spades. So if we add those up, each of them being out of 52, we have over here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we have in the middle have 1, 2, 3. And on the right hand side we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Which, as you can see from above, gives us 22 out of 52, which is equal to 11/26, which is 0.423, which is 42.3%. Now, if you would like to go ahead and try it with the formula to see if you get the same thing, to make sure you check your work, great, go for it. What I want you to do right now is take a look at this problem. I'm telling you it's inclusive. You pick a candy bar from a hat that contains Snickers, Twix, Milky Way, Skittles, and Laffy Taffy, and calculate the probabilities. Enter them into Edpuzzle, and then go ahead and see if you are correct. Let's go ahead and check this one out. Probability of Snickers or chocolate. So if we draw that Venn diagram, so we got Snickers over here, and we got chocolate over here. So we've got here Snickers. There's 1, and Snickers obviously is chocolate. We got 2 others that have chocolate in them, and we don't have any that are just Snickers because Snickers are made with chocolate. And so we've got here 1, 2, 3, 4, 5 candies. So we've got 0 out of 5, plus 1 out of 5, plus 2 out of 5. So that's 3 out of 5. Which is equal to 0.6 or 60%. Probability of Twix or a T in the name. So Twix and a T in the name. So first let's start with Twix and T in the name. That's one of them. We have 1 other that has a T in the name and none that are just Twix. So we have 0 out of 5, plus 1 out of 5, plus 1 out of 5. So that gives me 2 out of 5, which is 0.4, which is 40%. Skittles or non-chocolate. You got Skittles, you got non-chocolate. You got Skittles and non-chocolate, that's one of them. And there are none that are just Skittles. We have 1 other that's non-chocolate, so it's going to follow suit exactly with the last problem. So 2/5 or 40% or 0.4. What I want you to do right now is go ahead and try the U-Try problem. Give your answers into Edpuzzle. And as always, bring any questions with you to class tomorrow.